The left end of a long glass rod, 6 centimeters in diameter, has a convex hemispherical surface, 3 centimeters in radius. Well, we need to picture to make a figure of this so we can have a visual to understand this. So the refractive index of the glass is 1.60. We need to find the position of the image. So position of the image if the object is placed on the axis of the rod at the following distances to the left of the vertex of the curved end. So A infinitely far, 12 centimeters, and 2 centimeters away. Well, to better picture this problem, let's draw it. Well, here's our rod, a very long rod that has a hemispherical surface. Okay, here's the hemispherical surface, and this is the rod. And the rod has a and it's a very long, it says it's a long and it's glass, but it has a diameter of let's call this one as a D, okay, and diameter of 6 centimeters, and the 3 centimeter in radius hemispherical surface. So this hemispherical surface has a radius of, okay, so this is the radius of 3 centimeters. I'm going to pull this out as well, 3.00 centimeters. And then we know that the index of refraction of the glass, because the rod is from glass, is 1.60. Now we want to find out what is the position of the image if the object is, okay, so it's our givens. So let's say the object at the case, at the first case, the object is the infinity. And part B, the object equals 12.0 centimeters. Part C, the object distance equals 2 centimeters. And we want to find out the distance of the image in each case. Here's one important thing that we need to identify, that the glass rod is in the air. So therefore, outside of the glass, we're going to call it N air, which usually equals 1.00, and then N glass here equals 1.60, and then whatever the object we have, it should be outside of the glass, let's say here, and somehow we need to get some kind of an object inside the glass. Okay, well, let's try to remember what do we know about the spherical surfaces refraction. For the refraction of the spherical surfaces, we know that N1 over the object, okay, plus N2 over the image should equal N2 minus N1 over the radius. Okay, so if we apply that for our first case, A, our N1 is the air, N air, because our object is in the air. So distance of the object would be, let me just write a general case here, dO plus N2 is the glass, so it's a N glass over the image because the image is in the glass, and that equals N glass minus N air divided by the radius. Okay, so remember, we're looking for distance of the image. So it seems like in this equation we we know everything but the distance of the image. For the first case, our DO is equal to infinity, then I can rewrite this equation as n air over infinity plus n glass over di equals n glass minus na over r. So this, anything divided by infinity is gonna approach to the 0. From here I can find the di equals n glass times r divided by n glass minus na, n air. So let's plug in the numbers. So we have 1.00 for n, oh I'm sorry, for glass. So we have a 1.60, and the radius would be positive 3.00 centimeters. This is positive, and n glass is 1.60 minus n air is 1.00. That will give us a result of positive 8.00 centimeters, or we can say 8.8 centimeters to the right of the vertex of the curvature. Okay, so for the part B, okay, so this is our answer for part A. For the part B, we're going to use the same equation. Part B, we will only plug in DO as a 12 centimeters. So then we will have an so I'm going to use this equation. Let me box it in pink so you would see. I'm going to use this pink equation, pink boxed equation, and plug in the numbers. So for n air, I have 1.00 divided, for the distance of the object is a 12.0 centimeters, plus n glass is 1.60 divided di is what we're looking for, equals 1.60 for n glass minus n air 1.00 divided by the radius positive 3.00 centimeters. Now to solve this for di, we just need our calculator, and that will give us di equals positive 13.7 centimeters, which says the image is 13.7 centimeters to the right of the vertex. Let's box our result also for this case. And then finally for part C, where the DO equals 2 centimeters, the process is the same. We're gonna do plug in the numbers 1 over, instead of 12 we're gonna do 2 centimeters plus 1.60 over di equals 1.60 minus, okay, let me just write it better, 60 minus 1.00 divided by 3.00 centimeters. And so this will give us a value of di equals negative 5.33 centimeters, which means our image will be in a different side to the left of the vertex, so pretty much in the air. Okay, so this is our answer. So let me just summarize it. So this would be to the left of the vertex. This would be to the right of the vertex. And of course this one is also to the right of the vertex. Thanks for watching. Stay tuned for more to come.